Okay, this is section 6.6, and we're in day 3 now, and we're talking about the composition of functions. So we've done addition, we've done subtraction, we've done multiplication, and we've done division. Now we've got what we call compositions. So you see this symbol, it kind of looks sort of like a multiplication symbol, but it's really like an O. So a lot of times you'll hear say fog or goth. Well, that's not really how you say it. This is F composition G. Okay, or G, if I put G first, composition F. What this means is we're going to take the function G, whatever that is, and put it into F for the variable. So it's always the second letter. The G is going to go into the F in this case. Now, if they were flipped around, you would put F into G. Now, as we go to look at this, again, how do you find the composition of functions? Really, the composition of functions is really, truly substitution, okay? That's all this is a fancy way to substitute. So you're going to take one of the expressions and put it into the other function for the variable. Now, you'll have to use some multiplication, so you might have to distribute. You'll have to use some FOIL, or rainbows, or box method. And then you're probably more than likely going to have to combine some like terms as well. In terms of domain parts, we are not identifying any domains. You don't have to worry about that part. Okay, so the only thing you need to do is worry about being able to substitute and then simplify. Okay, so let's take a look here at the first few examples. Example number 1, it says perform the indicated operation. What this means, again, is that we are going to take the function G and put it into F. Okay, so we're going to take the function G, put it into F. So what we're going to do here is we're going to take G, the second one, that's this equation right here, and we're going to put it in for every x we see. Okay, and then we got to simplify it. So instead of x squared minus x, for every x I'm going to put a 3x plus 2. So this is 3x plus 2 squared, and then minus a 3x plus 2. Notice every time I put something in, I always put it in parentheses. Okay, well, 3x plus 2 squared is the same thing as this, 3x plus 2 times 3x plus 2. There's two of them. And here's where you're going to have to use the FOIL method. So first times first, that's 9x squared. And then outsides, 3x times 2 is 6x. Insides, that's also 6x. And last is plus 4. So now it's about combining like terms here. So 9x squared plus 12x and plus 4. So that's what we're going to put in here. That's what 3x plus 2 quantity squared is. So this is going to be a 9x squared plus 12x plus 4. Then we're going to take this negative and we're going to distribute it, just like you would do if we were adding or subtracting. So this becomes minus 3x and minus 2. Okay? And now, at the end here, all this is doing the best you can to combine all your like terms. Well, these guys are like terms, the positive 12x and the negative 3x, and then you got positive 4 and negative 2. 9x squared doesn't have any like terms at all. 12x minus 3x is 9x. And then positive 4 and negative 2 is positive 2. And you have completed your first composition problem. Okay, so second example looks a little different. You only see one function. Well, what this tells us here is we're going to take f and put it into itself. So we're going to take f and put it into itself. Well, remember, f of x is negative 3x and minus 2. So what I'm going to do is I'm going to take negative 3x minus 2 and put it in for that x right there. So this is going to be negative 3, and instead of an x, we're going to put a negative 3x minus 2, and then minus a 2 after that. Okay, so now, in order to simplify this one we're going to distribute the negative 3. So negative 3 times negative 3 is positive 9x. Negative 3 times negative 2 is positive 6. And then we're going to subtract 2. And then we have some like terms to combine. So 9x and positive 6 and negative 2 is positive 4. And we are complete. That is our most simplified answer. Okay, so again, being able to figure out compositions, putting one function into the other, and being able to simplify. All right, you should be able to complete the first page here of your 6-6 day 3 examples.